Hello?
Hello, can I speak to Lina?
Speaking.
Hi, this is Hannah.
Hi Hannah, what's up?
Do you know about flip-flop? I'm not understand about flip-flop.
Yes, I know. Flip-flop is a circuit that has two stable states and can be used to store state information. Okay, let me show you the important part relates to flip-flop. Let's start with 5 steps to draw timing diagram. First, identify the types of flip-flop such as SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. Second step, identify the truth table by referring to the types of flip-flop. Third, identify the types of clock operation, either negative coin transition or positive coin transition. Next, draw the input sequence of the flip-flop. Finally, we can completely draw the output of the flip-flop according to clock operation and input signal. The first step to draw timing diagram is to identify the type of flip-flop used. The first one is SR flip-flop non-gate latch. Second one SR flip-flop NOR gate latch. Third, clock SR flip-flop. Fourth, T flip-flop. Fifth, JK flip-flop. And the last one is D flip-flop.
Before proceed to draw timing diagram, let me show you the symbols, circuits, and truth table for each of flip-flop mentioned previously. We start with clock SR flip-flop. Figure 1 shows the symbol for clock SR flip-flop. Figure 2 shows the circuit of clock SR flip-flop. And the figure 3 shows the truth table for clock SR flip-flop. The second flip-flop is JK flip-flop. JK flip-flop is a common variation of the SR flip-flop. Figure 1 shows the symbol for JK flip-flop. Figure 2 shows the circuit of JK flip-flop. Figure 3 shows the truth table for JK flip-flop. The third flip-flop is T flip-flop. T flip-flop is a simply JK flip-flop whose output alternates between high and low with each clock pass. Figure 1 shows the symbol for T flip-flop. Figure 2 shows the circuit of T flip-flop using NAND and NOR gate. The red line is the JK flip-flop, which is part of T flip-flop. Figure 3 shows the truth table for T flip-flop. This is D flip-flop. D flip-flop has just one input in addition to the clock input. Figure 1 shows the symbol for D flip-flop. Figure 2 shows the circuit of D flip-flop using NAND gate. The red line shows the JK flip-flop, which is part of D flip-flop. Figure 3 shows the truth table for D flip-flop.
As we know, there are two types of clock operation, which is positive edge trigger and negative edge trigger. In PJT, clock is activated by a PJT, but in NGT, clock is activated by an NGT. For PJT, when the clock changes from a low state to a high state, this is called the positive coin transition or positive edge trigger. For NGT, when the clock changes from a high state to a low state, it is called negative coin transition or negative edge trigger.
In this video, we have prepared one example. The question is, Using JK flip-flop with PGT clock, draw a timing diagram for Q and Q bar. Assume Q initials equals 0. Next, we are going to show how to solve the question. From the question, we need to know the type of flip-flop used and the type of clock required. The type of flip-flop used is JK flip-flop in PGT mode. Refer to figure 1. It shows the symbol for JK flip-flop with PGT. Next, we need to identify the truth table for JK flip-flop.
So now, take a look at the timing diagram produced. The clock pulse with label of clock, position of JK and the output Q and Q bar are included in the timing diagram.
Now, let's take a closer look at how the output Q formed for each input JK and clock change. At first clock, both input JK is 0. So, according to JK truth table, if J and K is equal to 0, the output is not changed from the previous state, which is called hold state. Since the previous state of Q is 0, so the output at this time is still 0. The current output state remains the same even if the JK input change as long as no clock is triggered. Now take a look at second clock. The input J is 0 while K is 1. So the output Q is 0. In this state, we call it as reset condition. Next, at the third clock, the input JK is same with the previous state, so the output state also no change. Take a look at fourth clock. The both input J and K is 1. According to truth table, if both JK is 1 state, the output will toggle, which is the output state will change from 0 to 1 or vice versa. And lastly, at fifth clock, the input J is 1 while input K is 0. The truth table shows the output Q is set state, which is Q is 1. Although the output shape is same as the previous state, which is called toggle state, but in this case, the output state is called the set state, that is the output state should refer the input state. The conclusion. In many situations, an output is activated only when the inputs are activated in a certain sequence. The output of the flip-flop changed state at a specific point on triggering input, which is called clock. So, we hope the notes prepared throughout the video may help you confidently to draw the timing diagram. Thank you very much. Bye!
Thank you so much, Lina. Now I'm understanding very well about flip-flop.
You are welcome.